Good morning, everyone. Welcome to another session of Physics Unveiled. And in this particular session, we are going to discuss a very important aspects of Newton's laws of motion and its application that is called free body diagram. The question, narration itself showing you that what is free body diagram? How come a body will be free? Okay. So before jumping into the actual free body diagram, let us understand that why actually we need it. Okay. So in our day-to-day life, we have we witness actually a lot of different kind of motions. Sometimes motions are free motions, sometimes motions are connected or constant. Okay. So in all these kind of motions, we sometimes been asked to find out certain quantities like what is the amount of force is acting on the body, how the acceleration of bodies are interconnected, and this kind of thing. So let us have some example so that you can understand that what we are going to explain in further of this topic. Suppose there is a body of mass 2 kilo and it has been applied a force of 5 Newton. And if I need to find out the acceleration, then it's very simple from Newton's laws of motion that acceleration F equal to m into a. So you may find the acceleration as F by m. Okay, so let's try to complex this motion again. Suppose there are 3 blocks involved. This is suppose 2 kilo, this is 5 kilo, this is 3 kilo. And now you are applying a force of 10 kilo. And instead of acceleration this time, if I have been asked that find force on 3 kilo by 5 kilo. Okay, so it will be a different problem. Suppose there is another question, another variation, like suppose the bob block is placed on an inclined wedge and it is coming down, suppose, and I have been asked that what is the acceleration of block. Okay, again a different scenario of motion is there. Suppose the fourth scenario is like this. Suppose there is a pulley and 2 blocks are suspended out using a rope. Suppose this is 2 kilo, this is 5 kilo. Find acceleration. Okay, suppose one more problem, just an variation. Suppose that there are 2 blocks and there is a pulley and this is connected and there is a block. Okay, find acceleration of block. Okay, that would be another problem, like suppose this. Okay, this. Suppose there are 3 blocks, M1, M2, M3. Find acceleration. So in all this problem, what you are seeing that in some cases the body are freely moving. There is no interconnecting bodies. In rest of like here, the body's motions are connected. This and this mass are connected through some rope. Okay, in this case also the mass are connected by through rope. In this case the mass are. So in this kind of motion are called constant motion. The motion is being constant through a rope. Okay, they are interconnected. Constant motion. So we'll be taking a separate topic on this. This is constant motion. This is constant motion. Okay. So how to solve actually all these problems? So before actually solving it, you need to understand that what kind of forces that are acting on this body. And based on that forces, we will be writing the laws of equation, laws of motion using the Newton's laws of motion, and eventually equate them to solve to find out the actual acceleration of the each individuals. Okay, so let us try to understand that what is the free body diagram. Let us take a very simple case right now. Just a simple block placed on a ground. Nothing. So in free body diagram, what you need to draw first? Free body diagram. First, fixed your coordinate system. Fixed your coordinate system. Why this is for? Because force is a vector quantity. So choose your origin, choose your positive, negative. Suppose that I am just choosing this table as origin, and this is my positive y-axis, and this is the x-axis. This is positive x, this is positive x, this is positive y. Second, find all the forces acting on object in consideration. Now this is very important. What is the meaning by object in consideration? Suppose I have been asked to draw the FBD, suppose FBD of M. FBD of M. I have been asked to draw the free body diagram of for the mass M. So I'll be just considering the force that is acting on mass M, not the force that is being exerted by mass M. Okay, so let us draw. Now see, the mass has it will be pulled by gravity, mg, and since it is in touch of a surface, so there will be a contact force, normal contact force. So these two forces are acting on this mass m. If I just want to draw the FBD of ground, FBD of earth, suppose, so in this case only, earth will be exerted by a force normal downward, and this normal force is by m. This normal force is by earth. This will be equal and opposite according to Newton's first law of motion. I'm not talking about the other portion like the earth will be pulled by sun and this and that. I'm not taking that macro level of forces right now. I'm just considering this small environment right now. Sorry. Let's have some another picture. Let us keep this mass on an inclined plane. Okay, so let's take this is y-axis, this is x-axis, this is origin. Okay, if you want to take like this, you're most welcome, but once you fix your origin, you have to keep it always in same fashion. Okay, so this and this both are allowed. Now this is the mass. Now there will be an mg, there will be a normal force. Okay, I'll just draw this normal force extend here. Now this is 90, this is 90 minus theta, and this is theta. So you can divide the mg in two components. This is mg cos theta, this is the normal part, mg sin theta. Okay, so because force is a vector quantity, you can resolve it. If you have not understood this, then you can see our foundation classes playlist for vectors, and there we have explained the concept of vector resolution. Now this is another diagram. Let's have another diagram one more time. Suppose this is the case. Suppose this is 2, 5, 3. Draw FBD of 5 kilo. Suppose. So let's for 5 kilo. This is the 5 kilo. Now 5 kilo will be, there will be this 5 kilo, 5G. There is a contact with 2 and 5. So there will be a contact force from the 2. Suppose I am 2, and there is a contact force from 3 as well. So 3, and there will be a contact force from ground itself. Okay. Now, why do you need the coordinate system? You can understand now. If I'm just considering the coordinate system like this, then you see that N3 is acting in the negative of x. This is acting in the positive of y. This is acting in the positive of x. And this is acting in the negative of y. Okay. So that's why. While solving the equation of motion, you need to include the sign of force as well. Okay. So let us solve few more problem of FBD. I hope now you are finding the topic very easy. Let's see. Now this is being pulled by a force F. This is a pulley. So what are the forces acting on this mass? Now see, this mass, there is a string attached. So there will be a tension force, and tension always acts, always pulls a point. Tension always pulls a point. So for this point, tension will be in this direction, pulling direction. And there will be an mg. There will be a normal force. This is the FBD of mass. Okay. If I just want to draw for the pulley, then there is a force F. The string is passing like this. So there are 2 points. Suppose this is a point P, this is point Q. So what is the pulling direction? This is a tension. That will be tension. Okay. Now let's solve few more cases. Okay. Suppose this is 2, this is 3. मान लो FBD of 2 क्या होगा? इधर होगा टेंशन. This is the point, pulling direction. This is 2G. This is tension. FBD of 3. This point, pull this direction, tension. This is 3. Since the rope is same, in this case rope is same, therefore tension is same. Okay. Rope is same and massless. Therefore tension is same. Okay. Let's see another diagram. Okay. This is 2, this is 3. There is a, for this particular diagram, FBD of 2. There will be a tension upward. There will be a 2G downward. And there will be a normal force. Okay, we may break this 2G into components as I have shown in my last diagram. This will be 2G sine theta, and this will be 2G cos theta. Sorry. Now, for this particular 3, now 3 is connected from a different string. So we may write it T1. There will be a 3G. If I just want to draw for this particular pulley, suppose that this is P, then this pulley will have 2 tensions, T1 and T1. And in upward direction, there will be tension T. Okay, because this rope is same, this rope is same, and this rope is same. This is rope 1, this is rope 2. Okay, clear? Now let's see some another problem. Okay, 2, 3, 5. Let's draw again for 2. There will be 2G and there will be a tension in upward direction. Suppose this T, this is rope 1. So this will be T as well. Now this is rope, different rope. This is T1. This is T1. There will be 3G and there will be 5G. Okay, clear? For this particular pulley, we may draw this is T and there will be 2T tension downward, T1 and T. Okay, so with this, we are nearly at the end of free body diagram. For certain exercise, I'm just leaving few questions for you, and if you can solve them, please post your solution to us in our email IDs, or you may post the link of your solutions as well in our comment box. So let's see. This is a wall. There is a block. Okay, and this block is connected over a pulley. Okay, this is M, this is M. Suppose M is heavier than M. Okay, clear? Now drawing another. Suppose okay. All the shadowed portion are ground. Okay, rigid surfaces. There is M1, M2, and M3. So draw the FBD of each block shown in figures. Okay, hope to see your solution soon, and we'll be coming again with another interesting topic of constant motions equations and their relationship, and post that you will be in a position to solve different kind of problem based on Newton's law of motion. Thank you and have a great day.